In the 19th century, scientists had done experiments and showed that light behaved as a wave. They thought the light was just a wave. And just like waves travel on water, waves of light needed something to travel through. They didn't know what that was. Scientists didn't know what that was. So they said the universe, which was the Milky Way at the time, must be filled with something we can't see. So they thought, well, let's call that something ether, and we'll explore ether. In 1887, two really smart physicists, two really smart guys, Michelson and Morley, said, look, we're going to measure the speed of light. We're going to measure the speed of light going towards the light. We're going to measure the speed of light going away from that. We'll be able to see the difference, and by looking at that difference, we'll know something about the ether. So they set up this big experiment, and they started measuring the speed of light very accurately, so they could detect the difference in the speed of light. Now the problem is, it didn't work. The speed of light always stayed the same speed. It didn't matter if we were going towards the light or away from the light. The speed of light didn't change like it should have. They couldn't figure it out. This was a problem for science because they had no idea how light worked after that. In 1905, Albert Einstein said, look, let's imagine that light isn't just a wave, it's also a particle. And if it's a particle, we don't need the ether. Light can travel without the ether. He goes, and also, let's imagine that Michelson and Morley, there's the speed of light. It doesn't change. What if it stays constant? So he took the constant speed of light and the idea of the photon, and he came up with the theory of special relativity. And our view of the universe started to change. A few years later, Einstein's walking down the street, and he sees a man fall off the roof. Well, it wasn't very fortunate for the man. Einstein called that the luckiest day in his life, because he realized as the man was falling, he didn't sense gravity. He was basically weightless. Gravity had no effect on him, and this gave Einstein an idea. Einstein said, hey, I'm going to do a little thought experiment. Let's imagine I have a room way up in the sky, and it's got some people in it. I drop that room. As it's falling, the people inside the room would be falling at the same rate, but they wouldn't notice that. They would essentially feel weightless because gravity's pulling at them the same way as it's pulling on that room. They would be floating around in that little room. Well, then Einstein said, well, let's imagine there's a flashlight in that room with the people. So as this thing is falling, you got the room, the people, flashlight falling. If I was watching this thing from the outside, they would all appear to be weightless. But here's the part that really got Einstein. The light coming out from the flashlight, that would fall also. Light is affected by gravity. This is huge. Light falls. And in Einstein's mind, he realized that gravity warps space and time, and everything that travels in it, everything that exists in it is affected by that warp, whether it's planets, stars, humans, or even light. An English astronomer, Arthur Eddington, read Einstein's papers. He said, look, if Einstein's right, I should be able to go during a solar eclipse, look at the sun and the stars around it, and if gravity really does affect light, I should be able to see that by looking at the starlight coming around the sun during an eclipse. So in 1919, he left England and went down to Brazil where there was going to be a total solar eclipse. And this is the picture that Eddington took. The stars in this picture aren't where they're supposed to be. It turns out that the sun's gravity had bent the starlight coming from these stars, just as Einstein had predicted. Einstein was right. Of course, this is the theory of relativity. So out of the mind of Albert Einstein, our view of the universe totally changed. This is the imagination of Einstein.